Hello class, I'm back and this is Mr. McAllen, and I want to show you in this lesson we're going to work on a difference quotient for a quadratic function, and the quadratic function is x squared plus 3x plus 2. So let's just remember what our formula is for the difference quotient. That is f of x plus h minus f of x all over h, and over here on the side we're going to just write out what the function was, and now we're going to write out I'll take you through the progression we had before. If I said what's f of a, everybody in class commented and said a squared plus 3a plus 2. If I said f of dog, and if we said what's f of x plus h, people said x plus h squared plus 3 times x plus h plus 2. So then at this point we want to simplify this term, and we would FOIL this and get x squared plus 2xh plus h squared plus 3 times x plus 3 times h plus 2. We take this quantity and subtract it. We subtract from it this quantity, so we write that out as x squared plus 2xh plus h squared. I'm just writing in what f of x plus h simplified to be, and I'm going to subtract from it and I'll put that in blue, x squared plus 3x plus 2, and that's all to be divided by h. Now, before we start doing a lot of cancellation, I commented in class to just take a look at the equation and identify what is going to cancel, and nice and neatly show the cancellations with just striking, because we're going to be subtracting this whole quantity. So the x squareds will disappear, the 3x will cancel with that negative 3x, and this 2 will cancel with that 2, leaving us with the quantity 2xh plus h squared plus 3h all over h. Now, we have one more step to do. Can we cancel the h's out in the bottom? So we have an h that's going to factor out of every term in the top, and indeed the h's cancel out, and our difference quotient is going to equal 2x plus h plus 3. Now here's the importance of what we did before. People were asking, what's the point of the difference quotient? If f of x is equal to x squared plus 3x plus h, plus 2, and its difference quotient is equal to 2x plus h plus 3, then you have a formula for that parabolic equation to predict what the slope is without doing much work. For example, if I knew the point was at 1, the value of this function would be 1 plus 3 plus 2, that would be 6. And if I knew the value at, let's say, 4, that would give me a value of 4 squared plus 12 plus 2, that would be 30. So the slope between these points would be 24 on 3, or the slope would equal 8. Now that's what you would have to do every time you wanted to find the slope between 2 points on any curve. But with the difference quotient, since you now have it figured out for this function, you just have to plug in the x value and the h value, and you automatically get the slope. For example, this was my x value, and my h value, remember, is the difference between the x values, is equal to 3. So when you plug in those values of 2 times 1 plus 3 for h plus 3, you automatically get the value of 8, which is the difference quotient or the slope between those two endpoints. And that's the point of having the difference quotient. In calculus, we're going to limit this h value, and we're going to force h to go to 0, so that instead of just finding a secant line, we can find a slope of a tangent line. And that is one of the fundamental principles in differential calculus that we'll be going into next year. Hopefully this helps, and feel free to watch this video as many times as you like to help refresh your memory on how to do a difference quotient. And I look forward to your comments tomorrow. So have a good night, and thanks for watching.